Welcome to Right. Welcome to Right Tuition Classes, children. We are doing ICSE 10 Physics. We are doing a revision of Physics Numericals. What I plan to do is every day I'll put some revision of 10 questions of the numerical I'll be putting up. So around 7-8 lectures of it I'll be putting up. So if you go through all the 7-8 lectures, I'm sure children, you should find numericals of ICSE quite simple. So let's begin. Now here, you can see here, question number 1 says, calculate the equivalent resistance between points P and Q. You can see here, point P is here, point Q is here. You have to find the equivalent resistance between P and Q. मतलब simple. P and Q का बीच में total resistance पूछ रहे हैं. तो आप इधर देख सकते हो एक नेटवर्क को. पहले नेटवर्क को सिंपल बना लो. कैसा? मेंटली, नॉट रीड्रॉ इट. ओके, लेकिन देखो बेटा, ये जो 10 ओम रेजिस्टेंस है और ये जो 10 ओम रेजिस्टेंस है, उसमें जो करंट इसमें से पास होगा वही करंट इसमें से पास होगा. फिर से मैं बोल रहा हूं, जो करंट ये 10 ओम से पास होगा वही करंट ये 10 ओम से पास होगा. दैट मींस ये दोनों जब सेम करंट पास होते हैं, that resistance, those resistance, we say they are in series. We say they are in series. So this orange color resistance, what I marked, you can see they are in series. Are you getting me here? Now you may be saying, sir, आपने इसको काय को पिकअप किया, इधर इधर काय को नहीं स्टार्ट किया? अरे क्योंकि जहां ज्यादा डेंसिटी है, जहां ज्यादा नेटवर्किंग है, जहां गर्दी है रेजिस्टेंस का, उधर से हम लोग स्टार्ट करेंगे उसको इजी करने के लिए. ओके, सो इधर this resistance 10 ohm, and so see my answer also. I'm going to write it like this, children. The resistance is 10 ohm and 10 ohm are in series. Let R1 be their equivalent resistance. Let R1 be their equivalent resistance. Therefore, R1 equal 10 ohm plus 10 ohm. So R1 equal 20 ohms. तो अब ये दोनों एक हो गया बेटा. अभी देखो इधर, प्लीज आप लोग, क्या आई टोल्ड यू ना, जहां गर्दी है, जहां ज्यादा नेटवर्किंग है रेजिस्टेंस का, उधर से स्टार्ट करते हैं. अभी देखो इधर, ये दोनों एक हो गया, R1 बन गए 10 ohm and 10 ohm. अभी देखना, प्लीज हैव अ लुक एट दिस. Okay, I mark this as green color. Okay, now look here. This current current starts from P, suppose. It passes through 3 ohm. But here, children, it gets divided. The current gets divided. So in this two, that is 10 ohm and 10 ohm, that is R1, and this 8 ohm, 5 ohm, different amounts of current flows. I repeat, ये 10 ओम और 10 ओम क्या बन गया बेटा? R1 बन गया. और ये जो 5 ओम है, ओके, देखो इसको, ये दोनों में डिफरेंट अमाउंट ऑफ करंट फ्लोस. जब अलग अलग करंट फ्लो होगा, those resistance are said to be in series, parallel. They are said to be in parallel. So now I'll just say now R1 and 5 ohms are in parallel, and let R2 be their equivalent resistance. R2, I say R2, equivalent resistance. Okay, now what will happen, children? I want this R2. So whenever the resistance are in parallel, we do it like this. 1 upon R2 is equal to 1 upon R1 plus 1 upon 5. I told you now, this 10 ohm has become 1, R1. Got it? Now this R1 and this 5 ohm resistance are in parallel. So let R2 be their equivalent resistance. 1 upon R2 is equal to 1 upon R1 plus 1 upon So what will happen here? 1 upon R2 is equal to, what is this? 1 upon 20 plus 1 upon 5 children. Now what happens here? 1 upon R2 is equal to, here please have a look at the LCM is, okay, those children, those are very weak. Okay, we'll do like this. 20 into 5, 100. 5 ones are 5. 20 ones are 20. I just cross multiplied. So what I get 25 upon 100. Now this goes in 25 stable. 25 ones are 25 fours are. So what happens? This is 1 upon 4. That means 1 upon R2 is 1 upon 4. So R2 equal reciprocal. So here also reciprocal 4 ohms. R2 is 4 ohms. That means अब ये पूरा R2 बन गया, पूरा R2 बन गया. ये R1 और 5 ohm को लेके मैंने उसका नाम R2 कर दिया, R2 कर दिया. Now you see, जो करंट 3 ओम से जाता है ये पूरा R2 बन गया. ओके, उसमें से भी जाएगा और इसमें से भी जाएगा, तीनों में सेम करंट पास होता है. गॉट इट? सो नाउ व्हाट आई विल से, दे आर इन सीरीज. The resistances 3 ohm, R2 and 3 ohm are in series. Okay, let R be the equivalent resistance. Let R3 be the equivalent resistances. Children, R3 be the equivalent resistances. Okay, so what is this R be there? Okay, so what is R equal? This 3 ohm, the resistances which are in series, you just add them. Okay, so R equal 3 ohm plus R2 plus 3 ohm. Now, what is R2, children? 4. So, 3 ohm plus 4 ohm plus 2 ohm. How much you will get, children? Sorry, this is also 3 ohm. Okay, I'm so sorry. So, what will happen? R is equal to 3 ohm plus 4 ohm plus 3 ohm. How much it had? 10 ohm. So, what is the answer, children? Equivalent resistance between P and Q is equivalent resistance between P and Q. Resistance between P and Q is 10 ohm. I hope this question is clear to everybody, children. We move on to the next question now. Question number 2 says, an object is placed at a distance of 8 centimeter from a converging lens. Converging lens का मतलब है convex lens. Converging lens का मतलब है convex lens. Of focal length 10 centimeter. Okay. Object is placed at a distance of 8 centimeter from the converging lens of focal length 10 centimeter. मतलब object कितना दूरी पर है? 8 centimeter दूरी पर है. किससे? Converging lens से. और focal length क्या है लेंस का? 10 centimeter. Pehla question, what kind of image is produced by the converging lens? What kind of, मतलब nature of the image आपको बताना है. What kind of image is produced by the converging lens? And can this image be taken on the screen? If not, why? So उसका answer देखिएगा. Focal length of the converging lens is 10 centimeter. Pehla I just mentioned focal length of the converging lens is 10 centimeter. Whereas the object is at a distance of 8 centimeter from the lens. Hence, the object is placed within the focal length of the lens. मतलब 10 centimeter का अंदर है. The object is placed within the focal length of the lens. So naturally, the image formed is virtual, erect, and magnified. Virtual, erect, and magnified. Now remember the second part of the question, B part. Can the image be taken on the screen? If not, why? This image cannot be taken on the screen because virtual images are seen within the lens. Virtual images are seen within the lens. Okay, children, we go to the next question, question number 3. What is given in this question? 3. Speed of light in glass is 2 into 10 raised to 5 kilometer per second. कोई बच्चा झलचो बोलेगा सर ये गलत है. 10 to 8 होता है। अरे बेटा इधर किलोमीटर है। Got it? अगर मीटर रहेगा तो 10 to 8, किलोमीटर रहेगा तो 10 to 5. So speed of light in glass is 2 into 10 to 5 kilometer per second. If the speed of light in air is 3 into 10 to 5 kilometer per second, what is the refractive index of the glass? Glass is called a medium. Glass is a medium. Okay, I want the refractive index of this glass medium. So remember, children, refractive index is given by the formula. Refractive index of a medium is in terms of speed is given by the formula. Refractive index is given by the formula. Speed of light in air. Speed of light in air. We call it as velocity of light in air. Okay, speed of light in air upon speed of light in that given medium. Okay, speed of light in that given medium. Which medium we are talking about here, children? We are talking about glass here. So I'll say speed of light in glass. Speed of light in glass. Please here, learn by heart. Okay, this formula, speed of light, refractive index of any medium is speed of light in air upon speed of light in that medium. Your refractive index of glass I want. Okay, what is the refractive index of glass? Refractive index of glass is, children, refractive index of glass is, refractive index of glass is speed of light in air upon speed of light in glass. The refractive index of the glass is, children, speed of light in air upon speed of light in glass. What is speed of light in air? See the question. 2 into 10 raised to 5 kilometer per second. What is speed of light in air? Sorry, speed of light in air is what, children? 3 into 10 raised to 5 kilometer per second. And what is speed of light in glass, children? 2 into 10 raised to 5 kilometer per second. The units get cancelled. 10 raised to 5 gets cancelled. You're left with 3 upon 2. That is normally 1.5. Okay. तो रिफ्रैक्टिव इंडेक्स कभी कभी एक क्वेश्चन आता है जो इसके साथ ही बता देता हूँ. रिफ्रैक्टिव इंडेक्स ऑफ अ गिवन मीडियम इज ऑलवेज ग्रेटर देन 1. Why? Because refractive index is a ratio of the speed of light in air upon speed of light in glass. And speed of light in air is the maximum speed, okay? Hence, the numerator is always greater than the denominator. Hence, refractive index will always be greater than 1. Refractive index of a medium will be always greater than 1. We can always ask you this question, okay? We go to question number 4, children. A man is standing between two cliffs. Cliffs मतलब छोटा mountains, okay? दो cliff के बीच में एक आदमी खड़ा है. A man is standing between two cliffs. He produces a sound, आवाज करता है, and hears two successive echoes at an interval of 3 seconds and 4 seconds. मतलब he hears two echoes. एक echo 3 सेकंड में सुनाई देता है और एक echo 4 seconds में सुनाई. If the speed of the sound is 330 meter per second, then what is the distance between the two cliffs? That means, just have a look here, children. I'll just try to understand. This is first cliff. Okay. I better put it. Okay. 1 minute, children. I'll draw it better. Okay. This is the first cliff, children. This is the second cliff, children. And the man, please have a look here. Let me say the man is standing between the two cliffs. Now, since he hears one echo in 3 seconds, another echo in 2 seconds. That means this man, he is standing between two cliffs. Okay, so this cliff is nearby, children, and this cliff is far off. तो ये नजदीक वाला क्लिफ से उसको ये जो फर्स्ट क्लिफ बोलता हूँ मैं इसको इसको मैं बोलता हूँ फर्स्ट क्लिफ. ओके, जो नजदीक है नाम दे दिया उसको फर्स्ट क्लिफ. ओके, और जो दूर है उसको नाम दे दिया सेकंड क्लिफ. ओके, इसको इधर से इधर तक कितना टाइम में लगा उसको 3 सेकेंड्स में. और जब इधर से इधर सुनता है उसको एक को कितना टाइम लगा 4 seconds. Or they are asking what is the distance between the two cliffs. I hope people understood. This man is standing between two cliffs. He is standing, first cliff is nearer. Okay, क्योंकि उसमें से echo hears in 3 seconds. Got it? So I call it nearer echo, or I call it first cliff. Okay, for nearer cliff or first cliff. And this clip is hearing the echo after 4 seconds. That means this clip, I name it as second clip. Are you getting me here? So what I'll do is, see, I'll tell you here, time distance is, I want the distance, okay? So see here, speed of, we are writing the solution. So speed of sound is equal to 330 meter per second. Okay, now I know formula for speed of sound. Speed of sound formula is speed is distance upon time. So I'll say distance from first cliff. Oh, sorry. Always remember one thing, children. Whenever echo sums are there, like a formula, see the distance covered by the sound, it goes and comes back to 2D, like, So I'll always say in my formula, speed of sound is 2 into distance from first cliff. Distance from first cliff. Distance from first cliff upon distance upon time taken. Are you getting me, children? So what is the time? Distance, speed of sound equal to 2 into distance from first cliff upon time. So speed is 330 meter per second. Okay, and what time it has taken? Please have a look here. Twice the distance from first cliff. Twice the distance from first cliff upon it has taken, please have a look here. It has taken, if you look into it, it has taken exactly 3 seconds for him. It has taken 3 seconds for him. So distance from first cliff upon from the first nearer cliff, it is time taken is 3 seconds. Are you getting me here? So the 3 seconds goes up. So 330 meter per second into 3 seconds is equal to twice, okay, twice the distance from first cliff. Okay, so what will happen, children? You can see here, this 2 will, this second and second gets cancelled. 330 into 3, 330 into meter into 3 meter, okay, 330 into 3, sorry, 330 meter into 3, the whole thing upon 2 is equal to distance from first cliff. Distance from first cliff. So naturally, children, what will happen, children? You can see here, 2 165s. Got it? 3 into 165 is how much? 3 5 is 15, 3 6 18 plus 1, 19, the 3, 495. This is 495 meters, okay? 495 meters, distance from first cliff. Now, same way, I have to find the distance from second cliff. How much time it is taking for the sound to reach 4 seconds. So what it will be, children? Speed of sound is equal to, please have a look here, speed of sound is equal to, I'm going to write it in short here, twice distance from second cliff, twice distance from second cliff, upon time taken, okay, how much time it takes. So this is 330. 330 into 2 is 4 seconds. 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 Forget about the units. I'm not putting the units right now because I want to write it in short. 2 into distance. Distance from second cliff. Okay. Upon, please have a look here. Upon time is how much time it takes, children. It has taken 4 seconds. 4. So cross multiply, children. Okay, this 2 ones are here, it gets cancelled, 2 twos are. Then when you cross multiply, you get 660 meters is equal to distance from the second cliff. Distance from the second cliff. Distance from second cliff. Now they want the distance between the two cliffs. Okay, children. So what will be the distance between the two cliffs? All can see. I'm going to do it here, children. I don't have place to do it. So I'm going to select here. Just see here. Okay. I'm going to write it here. I'm going to write it here, children. Okay. This is like my second page. Okay. Just have a look at it. I'm going to write it here. Therefore, distance between the two cliffs. रेड में लिखता हूं distance between the two cliffs. Between the two cliffs. Equal distance of the first cliff from the person was 495. I hope people can understand this. And distance from the second person was how much, children? 660. So when you add both of them, 5, okay, 15, 7 plus 4, 11. 11, 1155 meters. I hope people can understand this. Say 0 plus 5 is 5, 6 plus 9 is 15, 1 carry over, 5 plus 6 is 11. So 11, 1155 meters. I hope people have understood me. A little lengthy it became, but you can write it in short. I hope people have just understood it. Okay, that is what is needed. I move on to the fifth sum, children. The question is, calculate question number 5. Calculate the change in kinetic energy. They want a change in kinetic energy of a moving body if the velocity is reduced to 1/3 of the initial velocity. Matlab, whatever new velocity, initial velocity is, it is reduced to 1/3. So what will be the change in kinetic energy? So simple this question is. So what we'll do is, let's consider a body of mass and consider a body of mass m moving with the initial velocity initial velocity of initial velocity v. Got it? So naturally, what is kinetic energy? Initial kinetic energy, children? Initial kinetic energy will be equal to half mv squared, because this is a formula for kinetic energy. Okay. Now, please have a look here. Now, what the condition is now? The velocity is reduced to 1/3 of initial velocity. 1/3 of initial velocity. Got it? Initial velocity. That means of initial velocity. Children, 1/3 of initial velocity. 1/3 of initial velocity. So what is new velocity, children? Therefore, new velocity V is V1, new velocity I will consider as V1, okay? New velocity V1 will be equal to 1/3 of V, 1/3 into V, that is V upon 3, okay? So what is new kinetic energy? New kinetic energy is equal to half mv1 squared, okay? That is half into m into 1/3 into v the whole square. That is v upon 3 the whole square. You can take it, okay? So what will happen? Half into m into 1/9 v square. Now listen, what I do, this 1 upon 9, I remove it outside, and inside I write half mv square. Why did I do like this? Well, what is half mv square? Look at 1, okay? So naturally, new kinetic energy is 1/9 of initial kinetic energy. Initial kinetic energy. Initial kinetic energy. Are you getting me up from? I can say from 1. Okay. So now new kinetic energy is 1/9 of initial energy. So change in kinetic energy is change in kinetic energy equal kinetic energy, initial kinetic energy minus 1/3 of initial kinetic energy. 1/3 of initial kinetic energy. Now treat this. Please have a look here. 1/3 of initial kinetic energy. Initial kinetic energy minus 1/3 of initial kinetic energy. So cross multiply. This becomes 3 times initial kinetic energy minus initial kinetic energy, the whole thing upon 3. So ultimately it will become twice 2/3 of initial kinetic energy. I'm writing the answer directly. So what is the change? Change is 2/3 of initial kinetic energy. Change in kinetic energy is, hey, sorry. This is 1/9. Sorry, this is 1/9. Initial kinetic minus 1/9 of initial kinetic energy. So this will become 9 minus 1, 8, 8 upon 9 times 8 upon 9 of initial kinetic energy. Okay, children? A very simple question, children, but do it in this format. Or every sum you can do it in this format. Looks little lengthy, but quite an easy one. Okay, children? Please write it down and learn. Okay, we go to the next sum, children. Number 6, children. A very nice question. A radioactive nucleus undergoes a series of decays according to sequence. A radioactive nucleus undergoes a series of decay according to this sequence. Okay. Then, what is the sequence you can see here? The element nucleus X, first it undergoes a beta, you can see here. First it undergoes a beta radiation and changes to X1. This X1 undergoes an alpha radiation and changes to X2. Again, X2 undergoes an alpha radiation and changes to X3. If atomic number and if the mass number and atomic number of X3, the last one, okay, are 172 and 69 respectively, then what is the mass number and atomic number of this X? Got it? So simple this question is. One question you solve it, you understand all the remaining questions of this time. See, let atomic number of X be X and atomic number be Y. This X, its atomic number be X, and we take this as Y. Now, what happens? According to the law of beta radiation, whenever a beta particle is given out, the atomic mass number remains the same, but atomic number increases by 1. Atomic number increases by 1. Beta radiation जैसे ही देता है तो क्या होता है बेटा? Atomic mass number remains the same, but atomic number increases by 1. When a beta radiation is given out, atomic mass number जो ऊपर लिखा हो atomic mass number, नीचे लिखते हैं वो atomic number है. Atomic mass number remains the same, whereas atomic number increases by 1. तो क्या कर रहा हूं देखो, let the atomic mass number of X, element nucleus X, be small x and atomic number be Y. The nucleus X undergoes a beta radiation and it changes to X1. So this X, you can see here, this is X, atomic number, this is Y. Okay, it undergoes a beta radiation. So whenever beta radiation is given out, the atomic number, ऊपर का atomic mass number remains the same, X का X ही रहेगा, लेकिन atomic number जो नीचे है atomic number वो increases by 1. तो वो बन जाएगा Y plus 1. I hope everybody can see it. Now, this nucleus X1 undergoes a alpha radiation. जब भी alpha radiation आता है, what is law of alpha radiation? Okay, when alpha radiation is given out, always remember the atomic mass number decreases by 4 and atomic number decreases by 2. Atomic mass number decreases by 4, atomic number decreases by 2. तो ये X1 का जो X है, ऊपर atomic mass number is X. Atomic number is Y plus 1. It gives out alpha radiation. So what will happen? Atomic number should decrease by 4. So ये बन जाएगा X minus 4. And atomic number will decrease by 2. Say Y plus 1 will decrease by 2. Y plus 1 minus 2. You can see here. Okay, this remains. Now, again, this nucleus X2 undergoes an alpha radiation and changes to X3. So what happens? This X minus 4, X2, Y minus 1. Atomic mass number is X minus 4. Atomic number is Y minus 1. Again, alpha radiation is given out. Again, the atomic mass number should reduce by 4. And atomic number should reduce by 2. So what happens is, children, you can see here this X3 but they are given atomic mass number of X3 is 172 and atomic number is 69. That means ये जो है X minus 8 क्या बन जाएगा equal to 172. So X equal 172 plus 8, X equal 180. और ये जो है, please have a look here, Y minus 3 बन जाएगा equal to 69. Atomic number is 69. So Y equals 69 plus 3, Y equals 72. So now I'm writing the answer. What is X? Atomic mass number of X. Atomic mass number of X is 180. And atomic number of X is 72. A very simple question, children. I hope people are understood. We go on to the next question. Question number 7. Now, when you read a question of this type, children, an electric oven is marked 100 watt by 200 volts, 100 watt by 200 volts, 100 watt by 200 volts. Calculate the ratios of the element, energy consumed by oven in joules in half an hour, and time in which it will consume 15 kilowatt hour energy. So very simple sum, children. Remember only thing, it's a question of power rating. We call this as questions of power rating. Power rating का questions में please have a look here. Immediately in your mind should work. Like, power rating P. E is always VI. One formula. P is equal to VI. So if you want P is equal to, okay, we can also go for it. What is V is equal to? Please have a look here. IR. So I can also write it as I square R. I can also write it as I square R. Okay. P can be written. If I multiply by R, it will become R square and divide by R. So actually it is equal to P is equal to I square R only. So here I can write it as P is equal to, please keep in your mind, children, this is P is equal to V square upon R. I can write this as V square upon R. I can write this as V square upon R because V is equal to IR. So I square R square will become V square. So remember this formulas. P is equal to VI. Current rating का sums के लिए आपको जब भी आएंगे, you have to remember this formulas. Please have a look here. P is equal to VI. P is equal to VI. P is equal to I square R because this V is I square. V is equal to IR. V is equal to IR. So in place of V, when I put IR, it will become I square R. And if I multiply by R and divide by R, it will become P is equal to V square upon R. So these are the formulas you should remember. Okay. Now we start with this sum. You can see here, children, solution. Okay. You can see here the solutions. What happens is, you can see in this question, an electric oven is marked 100 watt by 200 volt. That means power is 100 watts. Okay. And potential difference is V is 200 volts. Okay. The first part of the question is calculate the resistance of the element. Calculate the resistance of the element. R किधर आया? देखो last formula में आया. तीन formula है. P is equal to VI. P is equal to I square R. P is equal to V square upon R. R किधर आया? I want resistance. So naturally R comes here. Got it? So what I'll do, I'll use that formula. P is equal to V square upon R. So what is R is equal to V square upon P. I want R. So I take R on top and P down. Now what is this? V square is 200 into 200. Okay. And what is this, children? P is 100. So 100 ones are 100 twos are. So it becomes 400 ohms. What it is? 400 ohms. So please keep it in mind, children. This is 400 ohms. This is 400 ohms. Okay. The second one, children, please have a look here. We go to the next one. This is question number 2, children. Now what they want, energy consumed by O1 in joules in half an hour. Energy consumed by joules in by O1 in half hour. Okay, time is half hour. So please have a look here, children. You also come across one formula, energy consumed. Okay, energy consumed. Please keep it in mind. This 1 watt hour. I hope people are understanding. The unit is 1 watt hour. Suppose it is 1 watt hour. 1 watt hour is always equal to 3.6 into 10 raised to 3 joules. Keep in mind, children. You have to learn it by heart. Suppose it is 1 kilowatt hour, it will be equal to 3.6 into 10 raised to 6 joules. Got it? If it is kilowatt hour, it will be 3.6 into 10 raised to 6 joules. Whereas if it is kilowatt hour, got it? It will be 3.6 into 10 raised to 3 joules. Now here, I want energy consumed by oven in joules in half an hour. Okay. So naturally, energy consumed is formula. Energy consumed is always equal to, children, हमेशा याद रखो, P into T. You cannot forget this formula. P into T. P is a power. T is the time in hours. Okay. So suppose this becomes energy consumed. What is P here? Power is 100 watt. Power is 100 watt. 100 watt into, what is this? Half an hour. Half an hour. Half an hour. Okay. So half an hour. So this becomes 50 watt hour. Two ones are 250s. But I want the energy consumed in joules. So 50 into 3.6 into 10 raised to 3. If I multiply this will give me joules, okay? So what happens is 50 into 3.6. When you multiply this will become 100 up into 360, 100 into 3.6 upon 2. That is 360 upon 2. Okay, 360 upon 2. See, this can be written as 100 into 3.6 upon 2. 50 can be written as 100 upon 2. So this will become 360 upon 2. Correct? This will become 160. So what happens is 160 into 10 raised to 3. Got it? Joules. That can be written as 1.6 into 10 raised to 5 joules. Okay. This can be written as 1.6 into the decimal. I want it here after one digit. Okay. So naturally, when I put there, I have moved to the left by 2 places. So naturally, I increase 2 zeros. So it becomes 10 raised to 5. Okay, children. Now, time in which it will consume 15 hours. The third part of the question is time in which it will consume 15 hours kilowatt hour energy. Time in which it will consume 15 kilowatt of energy. So naturally, it's a very simple question, children. Okay, they're not told me in joules or anything. I mean, nothing they mentioned. Just remember energy consumed. Same formula, energy consumed. You know the formula, children? Energy consumed is always P into T. Energy consumed is P into T. Got it? So energy consumed is 15 kilowatt hour. 15 kilowatt hour is equal to 100 watts into time. Okay, I hope people are understanding me. This is 15 kilowatt hours. 15 kilowatt hours. 15 kilowatt hours. Children, 15 kilowatt hour. 1 minute, children, I'll just show it to you. It is 15 kilowatt hour. So what is 15 kilowatt hour, children? This 15 kilowatt hour. So this is in watts, this is in kilowatts. So naturally, this is 1 kilo. Kilo is 1,000. So this is 15,000 watt hour is equal to 1,000 watt into T. Now 100 watt into T. This 100 will come down 1,500 upon watt upon 1,000 watt. This is hours, okay, into equal T. So 100 watt will get cancelled. So it becomes T is equal to 150 hours. 150 hours is the answer, children. 150 hours is the answer. I hope everybody understood this simple sum, okay? We go to the next sum. You can see, children, what is the question says, what would be the result when 600 gram of iron clips? You've got 600 gram of iron clips. Specific heat capacity of it is 0.48 joules per gram degree Celsius of this iron, okay? At 600 degrees, what is the temperature of this iron clip? 600 degrees. Are placed over 800 gram of ice. You're placing it over 800 gram of ice at 0 degrees Celsius and latent heat of ice is 336 joules per gram. That means, can 600 gram of iron clips, specific capacity of that iron is 0.48 joules per gram degree Celsius. It is at 600 degrees Celsius. Garam hai ye, hot body hai ye. You're placing it over 800 gram of ice, okay, at 0 degrees Celsius. So what is the result? They are saying. So what I will do is little common sense we have to use in this sum, children. Got it? So what I do, first I suppose I want to melt all this heat required to melt all 800 grams of ice. Suppose I want heat required to melt all 800 grams of ice. Why am I doing this? This is a cold body. Ice is a cold body. It is going to get heat from the, what you can say, iron clips. So what if how much heat I require to melt all these 800 grams? M into L, 800 gram into 336 joules per gram. Gram get cancelled, 800 into 336. When you multiply them, you get 2,68,800 joules. Okay, remember this. Whether I'm going to use it or not, I don't know. Okay, but I just found it out कि इतना हीट मिल गया तो सब आइस मेल्ट होगा. लेकिन हॉट बॉडी क्या आयरन क्लिप्स है. आयरन क्लिप्स का टेम्परेचर क्या है 600 डिग्री सेल्सियस है. अभी वो आइस का साथ मिक्स करूंगा तो उसका टेम्परेचर तो कम होगा. So suppose heat given out by iron clips to attain 0 degrees Celsius will be m into c into delta t. 600 gram into 0.48 joules per gram. Gram get cancelled into 600 minus 0. So what will happen, children? Gram gets cancelled. That means 600 gram into 600. 600 into 600 is 3, 3, 6 and 4 zeros. Got it? 3,60,000 into 0.48. 2 zeros goes away. Decimal gets shifted. So 3,600 into 48. And how much you get? 1,72,800. मतलब इसके पास प्लीज have a look here. अगर ये सारा का सारा आयन क्लिप जीरो में आ गया तो कितना हीट देगा वो बार? 1,72,800. लेकिन पूरा हीट आइस को मेल्ट करने के लिए कितना जरूरत है? 2,68,800. मतलब ये जो Q1 है is much greater than Q2 or not? That means all ice are not going to melt. That means all the ice in the all the ice are not going to melt, are not going to melt, are not going to melt. Okay, let X gram of ice melt. Got it? Therefore, please have a look here. Heat absorbed, maximum heat ice can absorb will be to melt M into L. Heat absorbed to melt, got it, is M into L. Only 1,72,800 heat is available to it. That is from the, when all the iron clips get converted to 0 degrees Celsius. So much heat is given out. and M is 336 into L, sorry. Got it? Sorry, L we know. I'm so sorry. What am I doing here? M we don't know. M we are taking it as X. Let X gram melt. Got it? X and L is 336. So what will happen? 1,72,800 upon 336 will be equal to X. Got it? So when I divide this, I get X equal 514.29, okay, gram, 29 gram, okay. Therefore, ice, how much amount? Not 600 grams. 600 gram of ice is there, but only 514.29 gram of ice will melt. Okay, this is the result. Are you getting me? This is the result of keeping the 600 grams of iron clip at 600 degrees Celsius placed over 800 gram of ice at 0 degree Celsius. I hope everybody has understood this. See, yeah, this was a short revision of all the questions. Okay, please write this question and solve these questions. Okay, somewhere rough, okay, in a bad handwriting, whatever it is, but solving like this, okay. So every day I'll try to put one, every 2 days I'll try to put one video like this of all the important questions, so you get used to it every day, okay, and you find physics very simple, okay, children. See you all. Bye in the next lecture.